The global response to environmental challenges depends on understanding how ecological systems connect countries, regions, and communities in ways that transcend political borders. Environmental services, such as climate regulation, water purification, and biodiversity conservation, operate at scales that rarely align with national jurisdictions. This disconnect creates externalities that are difficult to manage without coordinated international action. The topic introduces how shared natural systems require frameworks capable of harmonizing diverse political, economic, and ecological realities. As environmental pressures intensify, nations increasingly rely on international agreements and collaborative institutions to ensure that ecosystems continue providing essential services for human well-being and economic development. From regulating emissions that circulate through global atmospheric currents to safeguarding marine biodiversity that migrates across oceanic boundaries. The stewardship of shared resources demands cooperation grounded in science, policy, and diplomacy. The focus here is on how various actors, governments, multilateral institutions, and non-state organizations build strategies to address these cross-border issues. The image of representatives gathered around a world map symbolizes the need for dialogue, negotiation, and shared responsibility. The discussion emphasizes that environmental externalities often originate in one place, but impose costs on others, prompting the need for mechanisms capable of internalizing these costs at the international level. This perspective also highlights the increasing role of global awareness in shaping policy. Nations recognize that the resilience of ecological systems depends on decisions made elsewhere, which encourages engagement in cooperative platforms. These interactions help establish norms, promote transparency, and strengthen accountability, creating a foundation upon which global environmental governance can evolve. By framing environmental services as shared assets and externalities as common challenges, the content sets the stage for examining how international frameworks, agreements, and organizations structure collective action. The global dimension of environmental issues underscores why isolated national policies often fall short and why environmental protection has become a key pillar of international relations. The United Nations provides a cornerstone for global sustainability efforts through frameworks designed to unify countries around shared objectives. Central to this foundation are the Sustainable Development Goals, a comprehensive set of targets adopted in 2015 to integrate environmental protection with economic and social priorities. Unlike earlier development agendas, the SDGs apply universally, meaning that all nations, regardless of income level or political system, are expected to contribute toward achieving the collective vision. The framework emphasizes that environmental well-being is inseparable from human development. Issues such as poverty, social inequality, hunger, and health are deeply intertwined with ecological integrity. The SDGs therefore embed environmental service dependencies directly into development strategies, making clear that long-term prosperity cannot be achieved without sustainable resource management. The display of colorful goal icons serves as a visual map of interconnected aims, from clean energy and responsible production to climate action and life below water. Together, they represent a multidimensional agenda that guides policies, investment decisions, and international partnerships. This section reinforces how global commitments establish standards that shape national strategies. By framing sustainability as a universal responsibility rather than a selective concern, the UN encourages alignment across diverse political and economic contexts. This universality fosters cooperation, allowing countries to collaborate on shared priorities and learn from one another's experiences. Ultimately, UN global frameworks function as both a roadmap and a catalyst. They guide governments toward integrated policies, mobilize resources for global initiatives, and provide a common language that unites international actors in the pursuit of ecological stability and human well-being. Several major initiatives emerging from the UN system illustrate how international collaboration addresses specific environmental challenges. These initiatives showcase different approaches. Some target particular pollutants, while others promote broad regulatory standards or seek coordinated global action. One example is the World Health Organization Framework Convention on Tobacco Control. Although primarily a public health treaty, it carries significant environmental implications. Tobacco cultivation contributes to deforestation and soil degradation, while manufacturing processes generate waste that can contaminate ecosystems. With participation from 181 countries, the convention demonstrates how global agreements can reduce health and environmental burdens simultaneously. Another initiative involves chemical and waste management under Goal 12 of the Sustainable Development Agenda. Article 12.4 highlights the importance of environmentally sound management of chemicals throughout their entire life cycle, from production and transport to disposal. Proper regulation protects air quality, water resources, and human health by reducing exposure to hazardous substances. It also supports regulatory alignment across countries, preventing pollution leakage to regions with weaker standards. A third example is the Montreal Protocol, widely recognized as one of the most successful environmental treaties. By phasing out ozone-depleting substances, global partners worked collectively to restore atmospheric functions that protect life from harmful ultraviolet radiation. The protocol's effectiveness illustrates the power of binding commitments, scientific monitoring, and international compliance mechanisms. These initiatives reveal how environmental governance operates across different sectors and scales. They highlight the diversity of approaches required to address complex issues, whether through restrictions on specific chemicals, regulation of waste flows, or coordinated global phase-outs of entire classes of pollutants. They also demonstrate the importance of political will, scientific evidence, and cooperation in sustaining environmental services that support life on Earth. Multilateral environmental agreements, often referred to as MEAS, form the backbone of global environmental governance. They provide structured frameworks that enable countries to pursue shared ecological objectives through binding rules, negotiated obligations, and coordinated strategies. These agreements range from highly specialized protocols addressing specific pollutants to broad conventions that shape governance across entire environmental sectors. The architecture of MEAs reflects the recognition that environmental problems do not respect national borders. Pollution flows across rivers, the atmosphere circulates emissions globally, and ecosystems span political boundaries. As a result, MEAs create mechanisms that transcend individual jurisdictions, requiring nations to collaborate, share information, and implement agreed-upon measures. Central elements of these agreements include the codification of obligations and procedures. Clear expectations reduce uncertainties that could otherwise undermine cooperation. Institutional mechanisms ensure monitoring, capacity building, and dispute resolution, strengthening compliance and building trust among parties. The handshake depicted in the image symbolizes the diplomatic nature of these processes. Negotiations involve balancing economic interests, political priorities, and scientific recommendations. By embedding commitments within legal frameworks, MEAS stabilize long-term expectations and reduce the risks associated with unilateral actions or abrupt policy changes. Through this architecture, MEAS help align global environmental targets with national policies. They establish shared norms that guide domestic implementation while providing forums for continued dialogue, adaptation, and enforcement. These structures represent the international community's collective attempt to protect environmental services that sustain societies worldwide. Effective multilateral agreements rely on carefully designed components that ensure not only commitment, but also flexibility, fairness, and transparency. These structural elements determine how well an agreement can achieve its goals, while accommodating the diverse economic and political realities of participating states. One essential component is substantive commitments. These commitments establish quantitative targets for reducing emissions or limiting harmful activities. They define the concrete actions nations must take to protect ecosystems and regulate pollutants. Clear, measurable commitments strengthen accountability and enable monitoring over time. Procedural rights form another key feature. These rights include reporting requirements, monitoring systems, and mechanisms for resolving disputes. Transparent procedures allow parties to verify compliance, share data, and maintain trust. Without such mechanisms, enforcement becomes difficult and the value of the agreement is weakened. Adaptive mechanisms ensure that agreements remain responsive as scientific understanding evolves. Environmental science advances rapidly, and new evidence may require updated targets or stricter controls. Adaptive provisions allow agreements to incorporate these changes without requiring full renegotiation, making them more resilient and effective over time. Equity provisions recognize that countries vary significantly in economic capacity, institutional strength, and environmental vulnerability. Differentiated responsibilities, such as staggered implementation timelines or flexible financing, help ensure that commitments are fair and feasible. These provisions also promote broader participation by reducing barriers faced by developing nations. Together, these components create the foundation for agreements capable of managing complex environmental challenges. They balance ambition with practicality, flexibility with stability, and global goals with national circumstances. International cooperation often confronts significant obstacles arising from economic asymmetries. Countries differ substantially in their technological capabilities, institutional capacity, and the baseline quality of their environment. These contrasts influence the marginal cost of achieving environmental improvements, making negotiations complex and sometimes contentious. Industrialized countries typically have greater access to clean technologies and more resources to implement environmental measures. As a result, they may face lower abatement costs but lack incentives to act without reciprocal commitments from other major emitters. On the other hand, developing nations may suffer higher damages from environmental degradation, yet lack the financial and institutional means to undertake large-scale mitigation actions. These asymmetries can create misaligned incentives. When costs and vulnerabilities differ, cooperation becomes harder to achieve. Countries may hesitate to commit to reductions unless assured that others will also contribute. To address these divides, equitable burden sharing becomes essential. Measures such as differentiated timelines, varied levels of obligation, and financial transfers help support participation across diverse economic contexts. The image of a negotiation table surrounded by flags illustrates the diplomatic balancing act required to bridge these differences. Trust building, transparent communication, and phased commitments help create agreements that acknowledge both global responsibilities and national limitations. Successfully managing economic asymmetries is critical for securing broad participation and ensuring that global environmental agreements deliver meaningful results. Environmental governance operates within a landscape where negotiation, monitoring, and enforcement all carry significant transaction costs. These costs arise from the need to share information, build trust, and establish consensus among diverse actors whose priorities may diverge. When monitoring technologies are imperfect or when verification is difficult, enforcing commitments becomes more challenging and more resource-intensive. Different governance structures experience these costs in different ways. Bilateral compacts involving only two parties typically encounter lower negotiation friction because interests are more aligned and coordination is simpler. These agreements can serve as templates for broader cooperation by demonstrating workable models. Regional frameworks introduce moderate complexity. They balance shared interests across geographically connected nations while addressing ecosystem-specific challenges, such as watershed management, regional air quality, or migratory species. Protection regional agreements benefit from proximity and shared environmental realities, but they require coordination among multiple governments with varying priorities. Global agreements face the highest transaction costs. Divergent political economies, differing levels of development, and varied national interests complicate negotiations. Sophisticated institutional structures and substantial capacity building are often required to facilitate broad participation and ensure compliance. This section highlights that addressing transaction costs is essential for the success of environmental governance. Investments in data systems, monitoring technologies, communication platforms, and institutional capacity can significantly reduce these costs, making cooperation more efficient and more durable. International non-governmental organizations play a crucial role in global environmental governance by operating independently of state mandates and bridging gaps that governmental frameworks cannot always fill. Their ability to work across borders without the constraints of political cycles or diplomatic negotiations enables them to act swiftly where governmental efforts may stagnate. INGOs contribute technical expertise, scientific knowledge, and on-the-ground insights that strengthen international policymaking. They often support the implementation of conservation initiatives directly within local communities, helping address resource shortfalls or institutional weaknesses. Their work is particularly valuable in regions where government presence is limited or environmental degradation exceeds national capacity. The image of volunteers engaged in reforestation illustrates the practical dimension of NGO involvement. These organizations frequently lead habitat restoration, sustainable land management, and community-based conservation efforts that deliver tangible ecological benefits. Beyond fieldwork, INGOs influence global negotiations by advocating for stronger commitments, raising awareness of emerging issues, and mobilizing public opinion. Their independence allows them to highlight concerns that may be politically sensitive for governments, such as marginalized community impacts or underreported environmental risks. Through these multifaceted roles, ITGOS help maintain momentum in global environmental action, ensuring that shared ecological goals remain active priorities even when political will fluctuates. The effectiveness of international NGOs stems from their ability to connect global objectives with local realities. Their presence within communities allows them to understand the sociocultural norms, economic constraints, and environmental pressures that shape daily life. This understanding ensures that conservation and sustainability initiatives are grounded in practicality rather than imposed externally. Community embedding enables INGOS to work directly with populations affected by environmental degradation, such as coastal fishers relying on mangroves or smallholders dependent on pollination services. This proximity supports strategies that reflect local priorities and enhances the legitimacy of environmental projects. In the realm of policy influence, INGOS extend their impact beyond grassroots work. They contribute to technical working groups, participate in international conferences, and provide independent scientific assessments. Their inputs help ensure that global negotiations incorporate diverse perspectives, especially from marginalized stakeholders whose experiences may be overlooked by national delegations. Funding mobilization is another critical dimension. INGOs often access philanthropic networks and flexible financing channels unavailable to governments. These financial resources support pilot programs, testing innovative conservation models, such as watershed payment schemes or community-managed forests. Successful pilots frequently scale into national or regional initiatives. Through these interconnected roles, INGOS serve as vital intermediaries connecting global visions for sustainability with the nuanced realities of on-the-ground implementation. Transboundary air pollution exemplifies how emissions generated in one location can produce environmental and health impacts far beyond their point of origin. Atmospheric processes disperse pollutants across hundreds or even thousands of kilometers, making it difficult to trace responsibility or implement localized solutions. Emissions such as sulfur dioxide from coal combustion, nitrogen oxides from vehicles and heavy industry, and ammonia from agriculture undergo chemical reactions in the atmosphere. These reactions generate fine particulates that travel across borders before being deposited on ecosystems in urban areas. The effects include acid rain, degraded soils, reduced crop yields, and increased respiratory illnesses. Because air masses move freely across continents, no country can fully protect its air quality through domestic policies alone. This borderless dynamic demands international cooperation, scientific coordination, and harmonized monitoring systems. The image of a large atmospheric plume sweeping across a landscape illustrates the magnitude and mobility of these pollutants. Transboundary air pollution also underscores the global nature of environmental externalities. While some regions may contribute disproportionately to emissions, others may bear heavier ecological and public health consequences. This imbalance makes shared responsibility, coordinated regulation, and transparent data exchange essential for effective management. Overall, this topic highlights the need for comprehensive international strategies that integrate science, regulation, and diplomacy to protect air quality and public health across interconnected regions. Understanding the economic and institutional dimensions of environmental cooperation is essential for navigating how countries manage shared ecosystems. Many of the difficulties associated with transboundary resource governance stem from institutional gaps or fragmented responsibilities that weaken coordination. One example is the property rights vacuum that frequently emerges across borders. When responsibility for water, forests, or other natural systems is unclear, different jurisdictions may apply inconsistent regulations, creating incentives for overuse or pollution. The absence of well-defined rights complicates long-term planning, limits enforcement, and weakens collaborative agreements. Monitoring requirements form another core challenge. Accurate information on environmental conditions is vital for managing shared resources, yet monitoring infrastructure is often unevenly developed between countries. Differences in data collection methods, reporting accuracy, and institutional capacity can generate uncertainty. When monitoring is incomplete or inconsistent, cooperation becomes harder as countries lack a reliable basis for evaluating environmental changes or identifying sources of degradation. Policy instruments play an important role in addressing these gaps. These instruments range from quotas and pricing mechanisms to joint regulatory standards and tax incentives that encourage sustainable practices. Their effectiveness depends on cross-border alignment. Otherwise, actors operating in different jurisdictions may face conflicting rules or imbalanced incentives. Coordinated instruments help harmonize expectations, promote compliance, and align policy goals at the basin or ecosystem scale. Taken together, these economic and institutional dimensions shape the foundation of international environmental cooperation. Where institutions are strong and policies well coordinated, shared resources are more likely to be managed sustainably. Where institutional gaps persist, environmental pressures intensify, and long-term ecological stability is placed at risk. Rivers, lakes, aquifers, and wetlands often cross multiple jurisdictions, creating natural interdependencies that link upstream and downstream communities. This hydrological connectivity means that actions taken in one area, such as water withdrawals, pollution discharges, or land use changes, directly influence environmental conditions in neighboring regions. The interdependence becomes particularly clear in agricultural and industrial contexts. Upstream withdrawals for irrigation reduce water availability downstream, affecting ecosystems, urban consumption, and hydropower generation. Nutrient runoff from farms or untreated wastewater discharge can degrade water quality far beyond the point of origin, creating algal blooms, oxygen depletion, and disruptions to fisheries. These effects cascade across borders regardless of political boundaries. This section emphasizes that hydrological systems require coordinated management to avoid creating winners and losers along a shared watercourse. Effective governance demands not only bilateral or regional agreements, but also shared monitoring systems and common quality standards. When river basins span diverse economic and political conditions, cooperation must balance competing needs, such as agricultural production, ecological preservation, and urban water supply. The imagery of a river running through multiple landscapes reinforces the interconnected nature of water resources. It illustrates how a single hydrological system sustains communities, ecosystems, and economic activities along its entire course. By understanding this interconnectedness, Countries can better design policies that maintain long-term water security while protecting ecological integrity on a basin-wide scale. Transboundary environmental cooperation often confronts asymmetries in geography, capacity, vulnerability, and economic incentives. These asymmetries influence how environmental impacts move across landscapes and how responsibilities are distributed among countries. Upstream-downstream dynamics serve as a clear example. Upstream regions frequently control water withdrawals, dams, and pollution sources that affect downstream users, when downstream communities have little influence over upstream decisions. Cooperation becomes difficult unless incentive mechanisms are established to align interests. Downstream dependency also shapes cooperation. Regions positioned downstream rely on upstream stewardship to maintain water quantity and quality. Because they face the highest exposure to upstream activities, downstream communities have strong incentives to negotiate agreements, fund monitoring systems, or provide financial support for upstream conservation. The need for harmonized standards becomes central in these scenarios. When countries maintain different regulatory thresholds for pollutants, agricultural runoff, or industrial effluents, shared water bodies become vulnerable to the least stringent standard. Harmonization creates a level playing field, enhances predictability, and reduces the risk of environmental degradation caused by regulatory mismatches. This topic highlights how cooperative frameworks must reflect the realities of hydrological and ecological systems. Effective agreements require recognition of power imbalances, economic disparities, and ecological interdependencies. By addressing these asymmetries, countries can develop governance mechanisms that ensure fair, transparent, and sustainable management of shared resources. Some environmental challenges extend beyond regional boundaries and fall into the category of global commons, shared planetary systems that include the atmosphere, oceans, polar regions, and biodiversity. These systems are not governed by any single jurisdiction, yet they provide essential services to all nations. Managing them requires frameworks that operate on a global scale. The concept of global commons underscores the difficulty of ensuring collective action for resources that no country owns, but every country depends upon. Atmospheric emissions, for instance, disperse freely around the world, meaning that local pollution contributes to global climate change. Similarly, overfishing in international waters threatens marine biodiversity and the long-term viability of fisheries worldwide. Planetary scale governance seeks to address these vulnerabilities. It combines scientific assessments with international agreements to regulate activities that affect shared global systems. The approach recognizes that unilateral actions are insufficient when environmental pressures accumulate globally. Instead, cooperation must align national interests with planetary boundaries. The visual representation of Earth emphasizes the unity of these shared systems and the idea that environmental stewardship at the global scale affects the well-being of all societies. Addressing global commons requires long-term commitment, monitoring systems capable of operating across borders, and institutions that support compliance and adaptability. By framing environmental challenges as issues of shared planetary responsibility, this topic reinforces the need for global governance mechanisms that safeguard ecosystems vital to collective survival. The Montreal Protocol stands as a landmark example of successful international environmental cooperation. Adopted to address the depletion of the ozone layer, caused by ozone-depleting substances such as chlorofluorocarbons. The agreement demonstrates how clear scientific evidence, strong political will, and effective institutional design can deliver transformative global outcomes. The protocol succeeded because countries shared a scientific understanding of the problem's causes and consequences. Measures to identify sources of emissions, attribute responsibility, and monitor progress created confidence in the agreement's effectiveness. Transparent scientific assessments helped establish a credible foundation for collective action. Another factor was the availability of substitutes. Industries were able to transition from harmful substances to safer alternatives at a manageable cost, reducing resistance to change and enabling compliance across sectors. Financial assistance for developing countries also played a crucial role by easing the technological transition and supporting institutional capacity building. Compliance mechanisms further strengthened the protocol. Regular reporting, verification systems, and enforcement procedures ensured accountability. By pairing ambition with support and clear rules, the agreement cultivated trust among parties and enabled coordinated global action. The Montreal Protocol remains a model of how countries can successfully confront a planetary threat. It shows that when scientific clarity, viable alternatives, and equitable support converge, global environmental governance can reverse environmental degradation and restore critical planetary systems. Comparative case studies provide valuable insights into why certain environmental agreements succeed while others struggle. These cases reveal that outcomes depend not only on ecological conditions, but also on institutional design, social engagement, and political incentives. One lesson concerns the role of institutional strength. Countries with clear regulatory frameworks, transparent monitoring systems, and adequate enforcement capacity are better positioned to implement shared environmental strategies. Conversely, weak institutions often hinder cooperation, even when ecological or economic incentives are strong. Another insight involves the importance of local engagement. Communities directly affected by environmental pressures often possess critical knowledge and have strong motivations to participate in conservation. Case studies show that agreements grounded in community participation tend to achieve more sustainable results as they integrate local priorities into broader governance frameworks. The analysis also highlights the need to adapt agreements to economic realities. In regions with significant economic disparities, cooperation is more successful when financial support mechanisms align incentives and reduce burdens on less resource partners. Overall, international case studies illustrate how environmental governance depends on the interplay between ecological factors, political dynamics, social structures, and economic capabilities. Understanding these interactions helps design frameworks capable of delivering durable and equitable outcomes. China's watershed management reforms provide an instructive example of how institutional innovation can address complex upstream-downstream conflicts. The challenge centered on the misalignment between administrative boundaries and natural hydrological systems. Upstream regions had few incentives to limit pollution or regulate land use, while downstream regions faced the environmental consequences of declining water quality. The solution involved creating watershed-level compensation mechanisms. Under this system, downstream regions provided financial transfers to upstream jurisdictions in exchange for improved water quality and reduced pollution. The approach aligned incentives by rewarding upstream authorities for conservation and sustainable land management. The results were significant. Water quality improved along key river systems, ecological degradation slowed, and interjurisdictional cooperation expanded. The compensation model also encouraged upstream investment in pollution control, soil conservation, and sustainable agricultural practices. By linking financial incentives to environmental outcomes, the system fostered a more balanced and cooperative approach to watershed protection. China's innovation demonstrates how economic instruments can address institutional fragmentation. It highlights the potential for creative policy design to reconcile conflicting interests in shared environmental systems and promote long-term ecological restoration. European agri-environment schemes illustrate how policy design can integrate agricultural productivity with ecological stewardship. These programs emerged in response to concerns about greenhouse gas emissions, soil erosion, water contamination, and biodiversity loss linked to agricultural intensification. At the core of these schemes is adaptive management. Farmers receive payments to adopt practices that provide measurable environmental benefits, such as reduced fertilizer use, improved soil conservation, habitat restoration, or conversion to organic production methods. Payment levels vary according to environmental ambition, allowing farmers to select options that align with their capabilities and land conditions. The schemes rely on standardized yet flexible frameworks. Clear guidelines outline eligibility, monitoring requirements, and expected outcomes, while leaving space for regional customization that reflects local conditions. This structure ensures transparency and accountability without imposing uniform prescriptions that may not suit diverse farming landscapes. Through these initiatives, Europe seeks to improve agricultural sustainability while maintaining rural economic viability. The schemes demonstrate how public policy can support environmental services, such as carbon sequestration, biodiversity protection, and water regulation, by aligning agricultural incentives with broader ecological goals. Looking ahead, environmental governance will confront a new set of emerging challenges shaped by demographic shifts, economic transitions, and technological advances. Urbanization pressures are among the most significant. As populations concentrate in cities, resource demand intensifies, increasing pressure on water systems, land availability, and waste management infrastructure. Urban growth also expands energy consumption and contributes to air pollution, unless mitigated through sustainable planning. Changes in consumption patterns represent another challenge. As societies grow wealthier, demand for energy-intensive goods increases, supply chains lengthen, and environmental footprints widen. Addressing these trends requires new strategies for circularity, efficiency, and sustainable product design. Technological change offers both opportunities and complications. Advanced monitoring systems, artificial intelligence, and digital tools can improve transparency, support enforcement, and enhance environmental modeling. At the same time, technological disparities between regions can deepen existing inequalities unless capacity building accompanies innovation, circular economy principles, closing loops, minimizing waste, and recovering materials have the potential to reduce environmental pressures significantly. Applying these principles at scale requires coordinated policies, investment in infrastructure, and widespread behavioral change. These emerging challenges point to the need for governance systems that are adaptive, resilient, and capable of responding to rapid change. The future of environmental sustainability will depend on institutions that can integrate technological innovation, economic transformation, and ecological stewardship in coherent and forward-looking strategies. Strengthening global environmental governance requires recognizing that environmental pressures are evolving faster than many existing institutions can respond. The path forward calls for cooperation that integrates scientific evidence, equitable burden sharing, and adaptive policy mechanisms capable of addressing uncertainties and emerging threats. Improving governance begins with enhancing institutional coherence. Fragmented responsibilities, overlapping mandates, and inconsistent standards undermine effective action. Streamlining institutions and improving coordination across sectors, such as water, energy, agriculture, and biodiversity, reinforces the capacity to respond to complex environmental interactions. Transparent monitoring and data sharing systems are essential for strengthening accountability. When countries rely on shared information, trust in the governance process increases, enabling more ambitious commitments. Continued investment in scientific research supports evidence-based decision-making and keeps governance aligned with evolving ecological realities. Cooperation also requires fairness. Ensuring that developing regions have access to financial resources, technological tools, and institutional support is essential for encouraging broad participation. Equitable mechanisms reduce disparities that often hinder global agreements. Finally, strengthening governance means fostering long-term commitment at both national and international levels. This includes adopting flexible rules, building resilient institutions, and supporting inclusive participation among governments, communities, and non-state actors. The underlying message is clear: protecting planetary systems requires governance structures capable of operating at the pace and scale of environmental change. By aligning global cooperation with ecological urgency, the international community can build a more stable and sustainable future.